So 4-3 notes, corresponding angles and corresponding sides. Okay, first off, what does corresponding mean? Same. Kind of, but I don't mind you saying the same. I'd say like same position. So a corresponding sides here, based on the labeling, AB is corresponding to DE in relation to the triangle. They're the same position. Well, what do you mean by same position? Well, AB is between the right angle and that circle symbol. DE is between the right angle and the circle symbol. So these are corresponding sides. Is that clear? Okay. So another thing, if you're like, what are all those markings? Well, we do know that's right angle. We should know that. The rest of them are just identifying markers. And what they do, yeah, there's angle marks. So like, this just means that being an angle marker, that's an angle marker. That's the same. That's all that means. This being like that one italic, that's one italic or one slash, that means they're the same. So it's just a way of labeling so you know which angles are where. Okay? You can see corresponding angles A and D, because they both have the circle. Corresponding angles B and E are both the 90. C and F both have the 1 slash there. Okay, sometimes they'll do stuff I've seen before, or we use a lot. And actually, it's interesting if you guys ever want to go further into triangles. Before here, I actually taught advanced geometry, and so we did a lot of triangle congruencies, and we did proofs of triangles. Okay, my previous job, so a little bit higher level. So you could do 2 marks. Okay, you could do a mark with a slash in it. All those things can give you just markers to make you know that they're the same. Okay, you can do whatever you want, really. You could put a star if you'd like. Okay, it doesn't really matter. Okay, so then the corresponding sides, A, B, D, E, we talked about that. B, C, E, F, A, C, D, F. Okay, make sure you look at the angles and the position because they're going to flip triangles on you, and it doesn't mean the top side and the bottom side are the same. You have to make sure that you're looking at them appropriately so that you can figure that out. Okay, next definition, similar figures. Have the same shape but different size. Okay, so they have to have the same shape but different size. So in order to have the same shape, they have to have the same what? Angles, exactly. You can't have different angles to have the same shape. Makes sense, right? A square, they all have to be 90s. Okay, so then all corresponding angles are equal. Okay, that's what I just said. They have to have the same angle. Okay, all corresponding sides are proportional. This is important. What does proportional mean? What does proportional mean? Yeah, you can divide it. That's fine. Okay, what else could that mean? Yeah, they have the same relation. All these are all good. Well, we just talked about scale factor, right? So scale factor is 1 to 5, 2 to 3. All those are ratios, and they're proportions. But what's important is that in order to determine if it's a similar figure, all 3 sides have to have the same proportion. If one is off by just a little bit, it's not proportional. That means it's not congruent or not similar. Does that make sense? So when you're going through here, and like let's say this side, see how that 1.1 to 2.2, that's 2 to 1. 3 to 1.5, that's 2 to 1. 2.6 to 1.3, that's 2 to 1. They're all 2 to 1, therefore it's similar. If this right here is 1.4, it's over. It's not similar anymore. Can't do it. Okay? All sides have to be proportional. So when you're doing this, you can't just test one and say, oh yeah, it's similar. Okay? It has to be all sides. Okay? Any questions on definition of similar? Good? Okay? So then equal angles, A and D, B and E, C and F. Proportionals, they're all 2 to 1. 2 times AB, 2 times AC, 2 times BC. Okay, perfect. Example 1, is triangle EFG similar to ABC? So now we're trying to ask the question, is it similar? So the first thing I want to look at is, are all angles the same? So 37, so yes. 90, yes. What about this one? It's not labeled. Yeah?
It's a square with a middle line through it.
Yeah, because if the other two are the same, then that one has to
Okay, correct. That's a very important point Ain just said. If you have two angles the same in a triangle, the third has to be. Because these two added up is 127. Triangles can only have what amount of angle? 180. So that's 127. That means we're at 53 here. You could write that if you want. It's 53 here as well. Okay, they're going to be the same. So all angles check out. We're good there. So now we want to look at proportional sides. So what sides are similar? So let's think about that. Sorry, say that one more time, Nolan. Just tell me one. EG and AC. Okay, so let's look at EG compared to AC. Okay, so EG is 3 compared to AC, which is 9. So 3 to 9 or 9 to 3, it's a 3 to 1 ratio. We're going this way, right? So we'll say 3 to 1. 3 to 1 times by 3 or divided by 3, whichever. So, okay, then we look at BC and FG. Okay, sorry, should have wrote this one the other way, but that's all right. 15 to 5, again, 3 to 1. Okay, and then 12 and 4, so that is also 3 to 1. So yes, this is similar. Wow, the pen's really not working with me today. Sorry, let me rewrite that. There we go. Okay. Okay, so let's check out the show you know here. Okay, is each pair of triangles similar? Show how you know. So we got 69, 69, 90, 90. So that means a third is. We're good there. This side is 2 to 1, 2 to 1, 2 to 1. So this one would be a yes. All angles are equal. All sides are proportional. And it's the same shape. Okay, how about this one? Let's see here. Okay, so this is what I'm talking about. They got turned on a bit. So 70 and 70. We don't know these angles. Okay, so yeah, so 27 to 25. Yeah, it just looks pretty off, doesn't it? I actually think that's supposed to, is yours saying 2.7? Does yours say 2.7?
Yeah, you can tell there's a little dot.
Yeah, so let's just, I think there's a dot here though. Yeah, I'm pretty sure they're decimals. Yeah, it's okay.
Yeah, because there's supposed to be a dot there too, Steve.
Yeah, it's okay. It makes logical sense for there to be a dot, 'cause that's clearly 4.1. Okay, we wouldn't have a 4.1 and a 41 and a 4, right? That'd be weird. Okay, so just what I want to look at real quick is, can somebody divide this for me? What is this? It's 1 point something. 2.7 divided by 2.5. 1.08. Okay, then can you do 3? Let's see, let's go. Yeah, 3 divided by 4.1. See that? Right there, we're already off proportionally. We can tell because, look, this side here is corresponding to this side, the BA and ED. BA is bigger than ED. Then I go to AC. AC is smaller than DF. That doesn't make any sense. Okay, so this one would be no, it is not similar. Yeah, not proportional is the one I'd say for sure. You could also say toward that it's not the same shape exactly. It's fine. Okay. Good? All right, let's just finish this thing off here. It's got a little bit left. All right, so here, Kyle's drawing triangles for a math puzzle. Are the triangles similar?
Yes.
Okay, 50, 85. This makes this have to be 45. That makes that 50. Okay, all of that's good. Are the triangles similar? You're saying yes, so let's make sure. 24 to 8 is 3 to 1. 21 to 7 is 3 to 1. Okay, and then 10.5 to x, I mean, we have to figure out what x is going to be. But we would assume if it's going to be similar that that would be times by 3, so that would be 31.5. So the missing side length would be 31.5. Okay. All right. Last thing here. Okay, this right here, FYI, that little marking is the similar marking. Okay, so if you want to put in shorthand instead of writing it, this is the similar symbol. Okay, so if you want to say something similar to something, you would write that. Okay, so then it says find the missing side length using a scale factor. So what we have to do is we have to first out figure out. The one thing, do you guys have any angle marking on yours? No. Okay, so that's not helpful, but they do say they are similar. So what happens is, since they say they're similar, we know the angles are the same. So then what you have to do is make sure you match things up. For example, GH and KL are similar sides. Okay, the way they label it, you have to put in the same order. You can't say they're similar and do a different order. Okay, they need to match up like with the same corresponding corners, essentially. Okay, so we want, you can set this up in a proportion if you'd like. So for example, x over 10 should equal 2 over 8. We know how to solve that. We've done that already. We cross multiplied. 8x equals 20. So the 8 went there, the 10 went there. Divide by 8. You're going to get x equals 2.5. So x is 2.5. And we essentially use the proportion. The scale factor way, so sorry, I actually did part B, but you can do either way you want. The scale factor way would be timesing 2 to 8 is a scale factor of 4. So if I have 10, I'm going to go 10 divided by 4, which gives me the 2.5. That's how you do it, the scale factor. Yep, so this right here, this right here is the proportion way. I set up the proportion. Okay, so this, we know that it goes 2 to 8, so the scale factor is 4. If I have 10 to undo a scale factor, I divided it by 4, and I got 2.5 again. Okay, so it's just the same thing. Okay.